Hi, welcome back to the Aurascape Lightboard Series. In one of our previous conversations, link over here, we talked about how malicious prompts have become the malware of the AI era. And we also talked about how these prompts can enter your world through the use of AI agents, um, using the ones built using technologies like MCP. Today, we are going to deep dive into MCP, understand what it is, the MCP specific security challenges, and some solutions that we offer at Aurascape for you to take control. I'm going to start with a very bold statement. Aurascape offers the world's most blank MCP gateway. Before the end of this conversation, I'll come back and fill that blank. But let's start with what is MCP? MCP stands for Model Context Protocol, a technology that was introduced by Anthropic less than a year ago. And its purpose in life was to provide additional context to your model or LLM in order to facilitate it to answer your queries. So when you query an LLM, it needs to know more about you, your environment, your systems, your data, so that it can do a good job in answering your questions. And MCP essentially provides that context. And the way it does that is by publishing the tools supported by these MCP servers, which then talk to your data and systems. The client can then call these tools, and it figures what tools to call based on help from an LLM. So that's essentially the architecture that it uses. Now, the spec for MCP itself has a lot of warnings. I'm listing a few here for you. It says you need a human in the loop for all the tool calls, which means you don't want to set it up so that tools just keep getting called automatically without any supervision. These tools also have text annotations describing what the tool does, saying, here are the inputs it takes, here's what it does, and here's the output it provides. And that annotation is used by the LLM to figure out what tool to call to do a job. And the spec says you should treat all of these tool annotations as untrusted. The next warning, you need to validate all the inputs into the tools and all the outputs coming back from the tools. And finally, you have to follow best practices in terms of data and network security. So, given all of these generic warnings, let's take a deeper look at the specific challenges that MCP poses. Here in this diagram, when I drew this client could reside on your desktop in your local environment. And in that case, it's called a local client. But it can also be part of your private app running in the cloud. So two different options. The servers also now can be deployed both locally in your environment, in which case they are called local servers, or something you access over the internet, in which case they are remote servers. So specifically regarding local MCP servers, the obvious challenge is you are now executing untrusted code in your environment, which is a big no-no. When it comes to remote MCP servers, you still have a bunch of problems. The first one being typosquatting, which is the bad actor names the MCP server very similar and close to an official sounding MCP server, so you start using it by accident. Impersonation, the second one. If you go to one of these popular registries today, an example being glamour.ai, and you search for, say, the Azure MCP server, you get about 6 responses. And when you look at them at first blush, they all look official. They all look licensed, secure, they have similar names, and you'd be hard-pressed to tell which one is the real one from Microsoft. So bad actors count on impersonating. The third risk is rug pulls. After an MCP server gains your trust, by behaving properly for a long period of time, suddenly one day it misbehaves. It pulls the rug from under your feet. And then finally, account takeover. Once an MCP server is trusted, you can then, as a bad actor, infect that MCP server and make it do bad things, right? So those are all various problems with remote MCP servers. And when you come to these LLMs, you have a whole slew of challenges there as well. LLMs can easily get overwhelmed when they have limited context windows. If you give it a lot of context, the LLM tends to forget pieces of that context, and you can't tell what it forgot and what it still remembers. With all this back and forth between client, server, and LLM, you send a lot of tokens to your LLM without any kind of real supervision, which means you can now start incurring huge costs in terms of LLM usage. So here are all the problems that the MCP usage could entail. So in summary, MCP really adds two things to your environment. We talked about one already. It adds context to your model, but it also now adds lots of security problems. Okay, so now let's take a look at what do we do about this. So I have the magnificent 7 points here. What you really need is you need to discover these MCP servers in your environment out there, understand the risk, understand the tools, what they do. You need to register them so that your developers in your enterprise only access tools that you have registered, where your admin can now sanction and whitelist the servers that can be used. They need to be able to sanction the tools within those servers that can now be used. The third point is you need a central location where your admin can observe all the tools being called and used and all the data that's being given to and returned by all these tools in your MCP environment. You need policies to be able to control what servers are allowed to be used, what tools are allowed to be used, what kinds of data are now allowed to be used by all of these tools and servers. You need to be able to audit this, meaning preserve all these logs for subsequent review. You need to be able to understand the usage in terms of how many tokens were used, how many users were using specific tools, what servers were used, how many times. You need to be able to account all these things. And finally, authentication. It's last but probably one of the most important things. MCP servers today support a free access, API key-driven access, and the recommended OAuth 2.1 access, which is the most secure. And so you have to make sure that a user is able to authenticate through the client so that the scope of that user's privileges, the role that the user has, is understood all the way through, so that only based on that user's role and scope, they are able to access the data through that MCP server. So that role and scope has to be preserved end to end through the OAuth mechanism. So that is the final sort of requirement for a good solution. The good news is at Aurascape, we have all of these pieces put together. And when you use your clients to talk to your LLM, whether they are running on your devices or in private apps, we have the Aurascape proxy that can monitor all the LLM tool calls and tool usage. We also have the MCP gateway that can sit between the client and the server when it's a server-side LLM, server-side MCP, or this gateway can sit between the LLM and these servers, where we can now rewrite the link to these servers as required by the client to point first to the gateway, and then the servers simply hang off that gateway. So either way, we have you covered. We can monitor all your client to LLM traffic, also all your client to MCP server traffic. And last but not the least, we have evasion prevention as well. So if your client were to accidentally talk to a rogue MCP server without going through the gateway, you will not be able to consummate this transaction, because no matter what, it still needs to talk to your LLMs as an assistant, and that is a point where we observe and control, and we would block that communication from completion. So now let's get back to where we started. So given this deployment architecture and feature set that we have across the proxy and the MCP gateway, Aurascape offers the world's most secure MCP gateway. Thank you.